Can C automatically detect when a variable goes out of scope and allow us to clean it up, free the memory, basically what destructors do in object-oriented languages? And the answer is sort of. So let's take a look. I recently made a video about constructor-like behavior in C programs, specifically how we can initialize modules automatically, and some of you expressed interest in automatic variable cleanup. Basically, when something goes out of scope, how do we automatically clean it up? So this might include freeing memory, closing files, closing network connections, updating data structures. And maybe you're like me, you forget to free your memory sometimes. It's really easy to get things all set up correctly on the front end because that's required for basic functionality, but you kind of forget to do some of the cleanup afterwards. And of course, many of you have called me out on that in previous videos. So the question is, can we get C to automatically clean stuff up for us when it goes out of scope? And I'm talking about custom cleanup, not sort of the automatic, it goes out of the scope and gets removed from the stack. That happens automatically. But I'm talking about, like, I have some code I want to run to clean up, say, a linked list or some other data structure, or free some memory that I had allocated when we're done with this function. And the answer is yes, sort of. It's not going to be perfect, but as always, we'll do what we can. We are going to be creating source code in this video, and as always, source code is available through Patreon. That's also where you can find ad-free viewing of my videos, as well as my monthly office hour. A huge thanks to all of you who make this channel work. But now for the code. Okay, today we're starting with a super simple C program. We just have a main function. We got some includes up here. We might even use all of them. I also have a makefile. This is going to compile my code. If you haven't seen makefiles in the past, check out my make videos or pretty much any of the rest of my videos. I pretty much use them all over the place. And so looking at this, let's look at just some simple examples where we might want to do some simple cleanup. Okay, so first let's come up here and let's make a function. I'm going to call this, just because I'm, I guess, lacking creativity today, I'm going to call it func1. And we'll come in here. Let's add void to say we're not taking any arguments. Now I want to do this in a separate function so that we can see when it goes out of scope rather than just when our program ends, which is what would happen if we go out of scope in main. So let's start up here and let's just say, let's do something simple. Let's just say we have a pointer to a bunch of characters. We'll call it buffer. And let's say we call malloc. We decide we want to malloc 50 bytes for this. And then here we might want to do something with that buffer. And then normally we would free the buffer when we are done with it, right? So this is common behavior. You need some memory and you need to determine at runtime how much memory it is. Obviously, that's not the case here because it's always going to be 50, but you know, sometimes we need to do things dynamically. For demonstration purposes, I am going to come in here and just add a little print statement that is going to tell us what memory, what address we actually allocated. So we're going to just print out the address of buffer. Notice I use %p here. That's going to print out, that's for pointer, not string. So if I did %s, it would print out whatever text happened to be in that memory, and it's uninitialized, so we could get all sorts of garbage. But %p, this is basically just printing out the address of the buffer that we allocated. And so yeah, this is a typical pattern in C. We allocate stuff, we do stuff with it, and then when we're done, we free it. Now keep in mind, in this case, this is memory that we're only using within this particular function. That is our focus today, local variables that exist within a particular scope. So this is not applicable to global variables or things that you're going to allocate in one function scope, and it's going to persist for a while, and then you're going to free it somewhere else. Today, we're not going to be able to help very well with that. But today, what I would like to do is to automatically determine when this variable buffer goes out of scope, and so we can clean it up automatically, because maybe I keep forgetting to free the buffer at the end of this function, and I'd like to make sure it just always happens when I'm done. And some of you are going to say, this can't be done in C, yet we're going to do it anyway, or we're going to try at least. So what we're going to use today is another attribute. We used GCC attributes in our constructor video. So check that one out if you didn't see it. It might help illuminate some things. But yeah, so we're going to use an attribute provided by GCC and clang. So it's not going to be completely portable. You know, if you got some funky C compiler, it may not be supported here, but it's available to most of you. So I think it's worth looking at. And it works like this. So if we come in here and we have our buffer here, and then we just come in here and we just decide, you know, I'm going to add an attribute to this buffer, and the attribute is cleanup. And then in here, we need to specify a cleanup function. So I'm just going to call it myFree. Again, call it whatever you want. Now, myFree doesn't exist yet, so let's come up here and implement it. But the idea here, before I actually write myFree, what I'm saying here is that, hey, when this thing goes out of scope, I want this function, myFree, to be called as a cleanup function for this variable. So if we come in here and let's just say we have void myFree, and then it's going to take one argument, which is going to be a pointer to the thing that we're trying to clean up. So because buffer is a character pointer, you're going to need a pointer to a character pointer. That's what's going to be passed in. Okay, so in this pattern, this is just what GCC does. So if this were an int, it'd be an int pointer. If it was a character, it'd be a character pointer. If it was a struct, it'd be a struct pointer. Also, I know that for some of you, multiple asterisks might make you a little nervous. I have a previous video that talks about pointers to pointers, big chains of asterisks, whatever. It might help calm things down a little if that is making you queasy. So I'll link down in the description to that video as well. Please check it out. But for now, what we're going to do is just say, so we're going to, all we need to do here is free the pointer that it points to. So we're going to free what P points to. And again, for demonstration purposes, let's add another print statement in here just so you can see what's going on. So, and we are again going to print out the address of the thing we're freeing. So this is part of the reason I'm printing this out is just so you can see that we are freeing the same memory. So the memory that we allocated, we are actually freeing it as opposed to some other memory that, we shouldn't be freeing. So that should be all for our cleanup function. Now we just need to come down here in main and we're going to call func1. And I'm going to come up here and remove this free because we shouldn't need it anymore. If this works the way that I'm telling you that it ought to, then leaving this in would actually mean we're going to try to free buffer twice and we'll get a double free error. And that could be, obviously that's going to crash our program. So, or at least it usually will if our allocator detects it. But so let's take a look. Let's see if this works really quick. Let's compile it and then we run it. Now you see the addresses don't match. That's because I made a mistake up here and I forgot to dereference my pointer here. So let's try it again. Okay, now it matches. So now you can see that the thing we're allocating, this buffer right here, is being freed. We're freeing the exact same address. And so yeah, so we're cleaning up the memory that we allocated, so that's great. It is a little bit ugly, and we'll take a look at that in a minute. But first, I want to basically look at a few other different variants on this idea, basically some other cases where you might want to have some cleanup. And so yeah, so let's add a little bit to our program. Let's say we have some kind of data structure, and maybe it has members in it. So let's say we have like a struct. Let's do it like this. We'll type def this struct. And let's say this is going to represent some kind of person, and let's give our people, so there's going to be a character pointer that's going to point to the person's name, and then let's give them an age. And some of you are going to be bothered by the fact that this allows very, very old people, so let's just do uint 8_t. I'm going to have to go up here and include standard int.h for that to work. Anyway, doesn't really matter. But yes, I'm going to leave this as a pointer. Now, yes, I know I could statically allocate. Like I could just say like names are always up to 256 bytes. But let's say that I'm going to store a lot of these names and we have some really short names and we have some really long names and we don't want to waste space by pre-allocating a really big name block of memory for every single one. So we're going to leave it as a pointer and we're going to dynamically allocate it every time you create a new name struct because we don't want to waste space. So we've got this struct. Now let's come down and there's some common things we're going to probably do with this struct. So let's make a function that's going to initialize it. Let's call it initialize person or init person. Let's take two arguments, a name and age. Oh, and we also need the thing we're initializing. So person pointer P. Okay, so then what we can do here is say P name. We want to just allocate space for this. We'll use just string length. And yes, I know string length doesn't do length checking. So yeah, so if you're worried about that or the security ramifications, sorry, bad news for you. I think I'm gonna just use string copy up here because I can. This is not a video about security. Check out my security video about why string copy has some problems potentially. So yeah, so only use this with names that you trust. But yeah, so we're gonna copy basically name into name. So what I'm doing, I'm allocating the size of the block being the length of the string that was passed in plus one extra character for the null terminating character. And then I am going to copy this name into this name, okay? And then we'll just move age over. That's gonna be easy. Okay, so this will set up our person. And now that we have this data structure in place, let's come down here and let's make a second function. I'm gonna call it func2. And let's say in here that we declare a person, one of these things we made called P1. And let's initialize our person. And let's pass in, so pointer to P1, the address of P1. Let's give it a name. Call it Toby Belch. And, oh wait, yeah, Toby Belch is 155 years old. Okay, and then also for display purposes, just so you can see what's going on when we run it, let's also add just a little bit of display here. And let's say the name is this many years old. Okay, so now one thing to keep in mind is that now in func2, okay, when we create this person1, and let's say we're doing something just with person1 with P1 in this function, but note that when we call init person, this is going to allocate space. It's going to call malloc here, not there, right here, and that's going to need to be cleaned up. Otherwise, we're going to end up with memory leaks. And so let's come up here and let's also make a little cleanup function. So we're going to say void cleanup person. And we will just pass in a pointer to a person like this. For display purposes, let's just, again, print out what we are doing. Clean up person. And just what are we passing in? Or let's do the information of the person that we are. So let's do just the name and the age. So the age. And then in here, let's just free the memory for the name. Okay, so this is our cleanup function that we're going to use for actually deallocating the members of this person. This function doesn't need to return anything. And keep in mind that there are other kinds of cleanup. Like I mentioned before, it's not always just freeing memory. That's just the example I'm using here, trying to keep it simple. But there are a lot of different things you might need to do when a particular object gets destroyed. You might need to close network connections or files or update dependent data structures. We're just keeping it simple today because I want you to see how we actually handle the calling of the cleanup functions. I'll leave the specific cleanup functions to you in your projects. But so now that we have this cleanup function, we can basically do the same thing we did before. So I can come down here and I can say, okay, let's just take this cleanup attribute and I can apply the same thing to P1, except we are going to say is cleanup person. And now our cleanup function will be run after func2 completes and our P1 variable goes out of scope. So when this variable goes out of scope, we're going to call cleanup person. Okay, so that's cool. Let's look at one other case. Now, what if we have two of these persons, but instead of getting a person just like we did with P1, what if I want a pointer to a person, right? So let's say we want to allocate this on the heap, then I could come in here and just say malloc size of person. And I'm going to, just so I keep this initialization here together, so let's put this one down here. So we have person1, we initialize it. So this is kind of one way that we could create a new person. But let's say we want to put it on the heap. For whatever reason, we end up with a pointer to it. And I could just put another one of these init calls down below this. You know, I'd like to not do this in two stages. So let's actually make this look a little more like, let's create a constructor function up here. So I'm going to come up here and make a function called, so we're going to call create person. We'll have it return a person pointer. And we'll have this do both allocation and we are going to do initialization in one. So we're going to say, let's say new person is, let's malloc some space for it. Size of person. Okay, so we're going to allocate this space for this new person. Then we will just use our init person function. We already have it, right? So then we can say new p, name, age, and then we can return new p. And I'm just doing this for convenience because I like the idea of rather than having this malloc here, let's just come in here and call create person. And let's say this one is Jacob. This one's 120 years old. Okay, so this is coming together nicely. The only problem is you notice that we still have a problem with our cleanup function. And that is that cleanup person is going to take it's designed for cleaning up a person, not a pointer to a person. So we're actually going to need a new cleanup function. I'm just going to call this underscore PTR. So cleanup person pointer. And then we can come up here and let's just make a new cleanup person pointer function. So it's a pointer to a person, right? Something like that. Let's change this printout. And rather than printing out all this stuff, let's change this and just print out the address, just so we know we're cleaning up the right thing. And then we will use our cleanup person function, since we already have it, and then we will free what PPP points to. Okay, so this is how we would clean up this. We're basically going to clean up the thing it points to, and then we're going to deallocate the space on the heap. So this is the cleanup that I'm going to want to do today. So now at this point, I think things should work. Let's go down and try it. We should get both of these getting cleaned up when they go out of scope. So let's just compile it, see what I messed up. Oh yes, I said P instead of P1. And let's make one for P2 as well. Okay. And now it all compiles, so that's great. And if we run it, oh, I forgot to call func2. That is a problem. It helps to actually call the code you're trying to run. Okay, so anyway, now func2, now this should actually work. So if we come in here and say example, well, now you're going to see, yes, not only do we free this buffer, but after we are done with basically this func2, once it exits, then we get this cleanup person pointer, cleanup person, cleanup person. So both of our people are getting cleaned up, and so that's great. But it's all still pretty ugly. This is a lot to type in extra every time I want to declare a variable that I just happen to want to get cleaned up, and it's definitely making my code a bit less readable. And if you've watched enough of my videos, you know that that's something that I really am not a fan of. So I want to keep the code easy to understand. If somebody comes along, I don't want them to be just like, wow, okay, why do I have all these attributes all over the place? That's a little bit annoying. And now might also be a good time for someone to say, well, just because you can do all of this, does that mean you should? And maybe not, but we're in this far, so why stop now? The goal of today is to make this work, so we're gonna try to process this. But this is not necessarily something that you need to do in your projects. So if you're just like, this is too ugly, just don't do it. But I think what I'm gonna do today, let's see if we can simplify these three cases just a little bit. So the first one, let's look at just the case where I have a block of memory and I want to make sure it gets freed. We could just say, okay, so this is pretty general, happens all over the place in code often where you're like, I'm going to malloc this memory and I just want it to get freed when we go out of scope. So what you could do, let's come up here and let's just define a couple of macros that might help us out. So like I could just say, let's call one auto free, right? So you could just do something like this and say, hey, anytime I see this auto free, that's a short version of this attribute. So we could come down here and then say, for example, rather than having all of this, I could just say buffer auto free equals malloc, right? And so this basically just puts me, it makes things a little bit less annoying. You can see that basically is going to compile just the same. It's going to be fine. Now, that doesn't work quite as well where you have more complicated different types. You've got more complicated data structures, each with their own cleanup functions. Like here, you've got two different types with two different cleanup functions. So maybe that's not necessarily going to help here as much. So let's do something differently. Maybe I come up here and we could just, let's make some more macros. So let's call this macro auto clean and we'll pass in the type. Okay, so the idea here is I want to make a macro that basically will define an auto clean type. And so if you give it a type, then basically it will just put the type and then our attribute cleanup. And then as far as, let's just assume, because I want to make this as generic as possible. So we're just going to say that the cleanup function is going to be cleanup underscore, and then let's concatenate the type on the end. Okay, so if I do auto clean person, it's going to be cleanup underscore person. And then let's make another one for auto clean pointer to a type. And so we'll do the same thing, except concatenate underscore PTR at the end. Okay, so now that we have these, we can come down here. So I've already updated this one to make it a little simpler, but let's look at these ones. So now this basically becomes auto clean person P1. Comment this out. This one is going to be auto clean R person 2, and now I can just take all of this out. And so now let's make sure we still compile. Okay, so we're still compiling, and if we run it, you can see it basically functions in exactly the same way. Now, this is still not as clean as it maybe could be if I had like, if I built this into my language, for example, but I think this is a lot easier to read than what we had before with all this attribute stuff. At least we're making it fairly clear what it is we're actually trying to do to this type. And I also like that it's fairly flexible. I can use it with basically any type I want. It doesn't have to be limited to person. If I had some other, type called pet, I would just need a cleanup_pet function or a cleanup_pet_ptr function, and that would take care of it. So as long as I have the matching cleanup functions, then I'm going to be great. So yeah, not too shabby. It's only going to work on local variables that are cleaned up when they go out of scope. So it's not going to work for every one of your variables or every case where you might want some kind of automatic cleanup scenario. It's also only going to work for GCC and Clang. So that's definitely a limitation, but it's a cool trick that I hope is useful to some of you someday in one of your projects. So I hope you learned something new. Have a great day, and I'll see you next time.